Look up at the night sky. What do you see? A velvet black canvas, sprinkled with the diamond dust of distant suns and ancient galaxies. For all of human history, we have stared into that darkness and wondered. We've asked questions that echo through the generations. Where did it all come from? Are we alone? Does it end? Is there a place where the universe simply stops? We are used to boundaries and edges, but the cosmos plays by a different set of rules. Imagine traveling in a straight line forever. You pass Earth, then Mars, then the distant gas giants. You leave the Milky Way behind. Would you arrive at a sign, "Universe ends here"? A cosmic brick wall, or something stranger? Let's talk about what we can see. There is a limit to our vision, not because our telescopes aren't powerful enough, but because of a fundamental law of the cosmos. The universe, as we know it, had a beginning. It burst into existence about 13.8 billion years ago. The Big Bang. This means light has only had 13.8 billion years to travel. Anything beyond the distance light could have traveled in that time is invisible to us. This cosmic boundary isn't a wall or a physical edge, it's a horizon of information. Imagine you're on a ship in the middle of a vast ocean. The observable universe is a spherical bubble of space-time centered on us. Its radius is about 46.5 billion light-years in every direction. How can it be 46.5 billion light-years if the universe is only 13.8 billion years old? The answer is mind-bending. The universe is expanding. Think of an ant walking on an inflating balloon. The ant walks a distance, but the surface stretches, carrying it farther. How can we be so sure about the Big Bang and the age of the universe? We have seen its afterglow. In the 1960s, two radio astronomers, Arno Penzias, Robert Wilson, they were trying to get rid of a persistent, annoying hiss in their radio antenna, but the noise remained. What they had accidentally stumbled upon was the oldest light in the universe, the relic radiation left over from the Big Bang. It would earn them a Nobel Prize. This faint energy is called the cosmic microwave background, or CMB. Think of it as the universe's baby picture. For the first 380,000 years after the Big Bang, the universe was an opaque fog of plasma. Light couldn't travel freely. When protons and electrons combined, the universe became transparent and photons were set free. Photons that have been traveling ever since, stretched into microwaves by expansion. Tiny fluctuations, 1 part in 100,000, were the seeds of stars, galaxies, and clusters. The blueprint of everything. There's another crucial piece of evidence that tells us we live in a dynamic, growing universe. It was discovered in the 1920s by Edwin Hubble. Hubble spent nights peering through the Hooker telescope at Mount Wilson. He measured spectra, the fingerprints of atoms, and noticed the lines were shifted toward red. This phenomenon is called redshift. Light from an object moving away is stretched to longer, redder wavelengths. You feel the Doppler effect in sound when a siren passes. Light behaves similarly. Hubble found the farther a galaxy, the greater its redshift, meaning the universe is expanding. It's the fabric of space itself stretching, not galaxies moving through space. Imagine raisin bread rising. Every raisin moves away from every other. No center, only expansion. This expansion drives cosmic evolution and sets the stage for everything we observe. For decades, astronomers thought the expansion must be slowing down. Gravity should act like a brake, pulling matter together and slowing expansion. But in the late 1990s, teams using distant type Ia supernovae as standard candles found the unthinkable. The universe is not slowing, it's speeding up. Something is overpowering gravity. A cosmic anti-gravity we call dark energy. Dark energy appears to be a property of space itself. As space grows, more dark energy appears, a runaway effect. Current measurements suggest about 68% of the universe's energy density is dark energy. Normal matter, stars, planets, people, is less than 5%. Dark matter is roughly 27%. Dark energy rules the rest. Because of accelerating expansion, galaxies will cross our horizon and fade into oblivion, leaving a lonely future for our local group. So what lies beyond the edge of what we can see? What is outside our cosmic bubble, past that horizon 46.5 billion light-years away? Science moves from observation into informed speculation. The simplest idea, beyond our horizon, is more of the same. This is the cosmological principle. On the largest scales, the universe is homogeneous and isotropic, the same everywhere. If true, the universe may be infinite, or it might be finite but edgeless, like the surface of a sphere. You can travel forever on a sphere without falling off. Similarly, our 3D space could loop back in a higher dimension. Even stranger, inflationary cosmology and string theory-inspired ideas suggest a multiverse. Our universe might be one bubble in a vast foam. Other bubbles could have different laws of physics. But at present, these ideas are untestable. There is no way currently to get a message from beyond our horizon. That edge is a veil separating what we can know from what we can only imagine. So, we return to our initial question. Does the universe have an edge? The answer is both yes and no. Yes, there is an edge to what we can see. The observable universe, a horizon set by light speed. But is there a physical edge to reality? Most evidence suggests no. It could be infinite, or finite and edgeless, looping back on itself in higher dimensions. Our discoveries humbled us. Earth is not the center, our star is one of billions, our galaxy one of trillions. Asking questions, building instruments, and thinking new thoughts matters. It is how we push the veil back. The journey to the edge is a journey into ourselves, a boundless invitation to keep exploring, to look up and see not an end, but an endless beginning.